Hello and welcome to the first video of about five where we will be really introducing the concept of the scientific method and how it applies to nutrition. So in this video we are going to define science, so you should know what science is by the end of it. We're going to describe the scientific method. We'll explain what makes a hypothesis good, as well as define hypothesis. We're going to differentiate between a hypothesis and a prediction, and we will identify the possible conclusions that you can come to based on the scientific method. So first of all, what is science? Science, simply put, is a way of knowing. It's a way of learning about the world around us by testing, by observing, by experimenting, and this is how we really gain scientific knowledge. Now it can be, science can either be descriptive or it can be hypothesis driven. So what do I mean by this? Well, descriptive science is really about observing nature around you, recording it, describing it, and classifying it in different ways. For example, looking under a microscope and observing cells and how they would function would be one way of depicting descriptive science, or describing what sort of nutrients are in a particular type of food, recording that, and classifying foods based on what type of food they are. So we might classify foods as being carbohydrate rich, or as being protein rich, or being maybe a member of the meat group, or a member of the potato group, etc. Now, where science becomes really powerful is when you use it as a form of inquiry. So this is where the hypothesis-driven science it comes in, and it's really a part of the scientific method. So with the scientific method, you may see it arranged in slightly different ways and different steps defined in different ways. This is how I like to do it, and so this is how you guys will be learning it. So you start with a question or a problem that you want to address, and then you will make observations that are related to that problem. What do other people know based on that problem? What observations have you made that are relevant to the problem? And then these observations are going to inform your hypothesis. So what is a hypothesis? It's really sort of a tentative explanation to the question that you have. Hypotheses then form predictions. Usually, it's not uncommon for them to make multiple predictions. These predictions then can be used to design experiments, and the experiments you will perform will allow you to come to a particular conclusion. Now, when you are testing your hypothesis via the experiment, really what you're trying to do is you're trying to prove your hypothesis false. Using the scientific method, there is no way to absolutely say that your hypothesis has been proven. You can just test it and collect more and more evidence. There's always the possibility that other information will come along that will make your hypothesis inaccurate, and you may have to readjust it at that point. So you can't ever absolutely prove a hypothesis. You can gather enough information against the hypothesis that it would seem to be unreasonable for it to be false, but you still can't say that it's absolutely proven. So from your conclusion, you can have from your experiment, you can come to two conclusions. Either the data will support the hypothesis, in which case you may use that to inform other experiments that you want to perform, or use it in other ways. But oftentimes you'll first want to test other predictions by the experiment. Otherwise, your conclusion might not support your hypothesis. The experiment comes out and it falsifies your hypothesis. Then you might want to go back and test other alternative hypotheses that came from the original question. So looking at how this might come along, you might have the question of what causes pellagra. So pellagra was a disease that became common in Europe when people took corn from the New World and started exporting it back, and it really became a staple food. Um, so pellagra is really a disease that is characterized by 4 Ds. There's diarrhea, there's the dermatitis, the inflammation of the epidermis, the skin. There is diarrhea, so dementia, diarrhea, dermatitis, and then finally, if you don't get those treated, if nothing happens to improve the situation, you ultimately result in death. So, as I said before, it started to appear in Europe when corn became a staple food. Corn also has little bioavailable niacin. So from this observation, you might you might form the hypothesis that pellagra is caused by niacin deficiency. Notice that this is not in an if-then statement. So this is kind of how hypotheses differ in science versus in statistics. Statistics is oftentimes mentioned as an if-then statement. Here, an if-then statement would be more of a prediction. So your hypothesis is a tentative explanation to the question or the problem. So what causes pellagra? Pellagra is caused by a niacin deficiency. So you might make predictions. For example, if you feed an animal a diet that's deficient in niacin, it will develop pellagra. This really is telling you, really designing the experiment for you. So your experiment is you take 2 groups of rats. One group would get a diet that has niacin in it. The other group would have an identical diet except that it's lacking in niacin. And then the outcome of that experiment might be that the niacin group develops pellagra. So your conclusion probably would be that your hypothesis is supported. You can't say that it's absolutely a fact that this is the case. It's possible that there's something else that is somehow missing that came along with the niacin that you weren't certain of. There's random chance it could have developed the pellagra even though this one group got niacin and then this group didn't. Just random chance that that's how it occurred. So you can't say with absolutely that niacin deficiency is what caused pellagra. However, this would strongly support that hypothesis. So essentially, you can say that we know that niacin deficiency causes pellagra, but there's the caveat that this is not an absolute knowledge. We can say it with very high confidence due to experiments that are similar to this, but other types of experiments as well. So this brings me back to hypotheses and predictions. So as I mentioned, hypothesis is really a tentative answer to the question. So it's an explanation to the phenomena that you are interested about. A good hypothesis must be falsifiable. So you must be able to test the experiment, and there must be an experiment that can actually prove this hypothesis false. It should be based on observations. So if your hypothesis is pulled out of thin air, this is not going to be a strong hypothesis. Now, a good hypothesis does not have to be true. You can have one that is falsifiable, that's based on observations, but when you actually test the hypothesis, it turns out that the hypothesis is wrong. So this was not a bad hypothesis. If you stick with this hypothesis, now that you have information that suggests that this is not the case, that might be considered a bad hypothesis because you've made new observations. But it wasn't a bad hypothesis to begin with because it was falsifiable. You made it based on observations. It just happened not to be true. So the difference between a hypothesis and predictions are that predictions are the outcomes you would expect to see if your hypothesis was true. They're often framed as an if-then statement. Your hypothesis usually will have multiple predictions that are associated with it. So if we look at this, before we had the statement here that if you gave rats a diet deficient in niacin, they would develop pellagra. Here, another prediction that you might come from this hypothesis is that if someone does have pellagra, you could give them niacin, and their pellagra would get better. So that would be another prediction. This didn't get changed down here, but this would be another prediction that then could test your hypothesis. Ultimately, the goal of scientists is to give their results out to the rest of the world. So whatever your results were, whether they're positive, if they supported your hypothesis, or whether you would reject your hypothesis based on this, regardless, you're going to report your work out into the world. So usually this is going to be in the form of scientific meetings or in scientific journals. In both cases, you're going to interact with scientists that are considered experts in this field, or at least as much of an expert as you. And it goes through a process called peer review, where scientists try to poke holes in your study, see if there's problems with it. You go back and forth, you defend it, you perform other experiments with their suggestions, and ultimately this work then gets disseminated out into the rest of the world, where it can be used to inform policy, inform your actual decisions, etc. All right, that's it for this video. I will see you in the next video here shortly.